A friend, having attended a couple of training programs on different approaches and techniques of value engineering, and who was later working on a lighting system design for an instrumentation reading panel, went to an extent that he started calculating back exact lumens required for a given place of reading the instrument, the place available for putting the lighting device, and calculated back that what he really required after proper quantification was a 67.5 watt of bulb for that application. He was happy so much that he suddenly expressed that, my God, what an amount of waste. We are using 75 watt bulb and what we really required was 67.5 watts. Quickly sent a note back to the purchase department and asked them to procure 67.5 watt bulbs only. Powerful enough as he was, his word was to be taken. The purchase department simply floated quotations, and out of the 10 companies that they inquired, only 2 of them they replied back saying that yes, they are in a position to supply this particular specification bulb. However, it is going to cost them about ₹1 lakh, because no one else in the world is going to use that specification, and it has only to be manufactured for these people. So the tooling cost and the development cost would have to be charged to them directly. However, parallelly, these 2 companies also offered that we are manufacturing a 60 watt bulb and a 75 watt bulb, each of which costs only ₹6. The choice was left back to my friend whether he should go to the accurate quantified calculations of 67.5 watt bulb or go for the nearest standard that's available in the market at a much cheaper rate. The basic question is, should we extend our quantification of the function to such an extent that it becomes irrelevant at a date? Should we not be objective enough to build up the gap between the approach and the application sensibly enough? Perhaps this is what is needed to be looked into. While we definitely talk about quantification of the function, it has ultimately to be an economic choice.
Siji, Radhika, Rani, Archana, Jayashri, Mary, Shailasri, Deepa, Nilofer, Anuradha.
You must be wondering whether the director has taken a wrong sequence, like a classroom like this. But you know, no professional does that mistake. Value engineering or value analysis is equally applied even to a situation like this classroom. Let us take the case of this teacher and the students. What is the primary function of a class? Is to teach the students, not to take the attendance. But if we take a quick look at this, it turns out for a common classroom of this size, with about anywhere between 80 to 100 students per class, with an average of 8 to 10 seconds per student for an attendance, we lose anywhere between 10 to 15 minutes of the precious 50 minutes period. The basic question is, can we afford losing this much amount of time just for attendance? What for we are taking attendance? Is it to know the attendance and presence of the student or the absence of it? Looking at the present way, we are marking both, whether he is a present student or he is absent. But perhaps what could be done is, we could have marked only either the present or the absence of the student in the relevant columns. Making this, we again look back into that the easier options is that putting absence is much more easier than putting the presence. And once you know one, the other is contrary to that and complementary to that. So why not we have only one of them instead of both? Now, few problems might come which we understand, that if you are putting only the absence in the relevant columns and leaving the other columns blank, there is a danger of someone putting either an absence or a presence at a later date. The question is how to solve that problem instead of dropping the idea. Alternatively, we start marking the absence in the consecutive columns, one after the other, and over a period of time, the spread of the absence line of individual students might give a direct indicator as to how much absence each of the students is, because in the whole year a student might be just absent for 20, 25 or 30 days. For that, why should I keep on taking his absence or presence for all the 300 odd working days in the year? Second problem could be, at a later date, if you want to know on what particular day the student was absent, perhaps that will be a problem. We can have an alternative way. Instead of using a letter like A for absence or a cross for absence, we can use the date and the month concept, that in that particular block you put like 27/6, which would indicate that the student was absent on the 27th of June, and so on. And at the end of the year or any part of the year, it will give you a bird's eye view about the total nature of the absence of various students, and once someone has crossed a certain given limit, he would automatically be identified instead of having to go through the process of totaling up and calculating the total absences from the whole long list of 300 odd working days. And ultimately, what we can look forward is that instead of a 12 detailed pages of register, my new attendance register might look to be only of one page, for which definitely I can afford spending a little more money and make it a more appealing and better looking attendance sheet than what it is today. This is an operation called gold wire bonding, being used to join two different electronic components which are very sophisticated in nature. The requirement of gold in this particular case has been merely because of the electrical conductivity requirements of the system. This operation can be equated to that of either soldering or brazing, or maybe even welding for that matter. What really depends on is the ultimate requirement of the system for which we are carrying out a process or an operation. The selection of the material along with the specifications of the material, the sizes, are purely decided by the designer himself. Once the item is decided, it is merely a matter of a regular production as what we are seeing right now. Coming to the requirements, if it were purely the requirement of a mechanical strength, maybe welding might have been another process solution. But being electrical conductivity requirement, we have perhaps decided about gold as the media in this case. Value is a relationship between the functional worth and the cost of the item. And any value analysis exercise can be very effective only when the related information with respect to the function and the cost has been correctly and accurately collected. When we are talking about the collection of information, what really matters is the information regarding the material specifications, the design requirements, the sizes, dimensions of the material, the working conditions in which the product is supposed to be working, the desired life of the product itself, the reliability expectations from the product, and other connected items of information. Similarly, on the cost front also, we have to necessarily collect information regarding the cost of the materials, the cost of the labor involved, and the related costs of the overhead expenses allocated for costing purposes. Let us have a quick look at the application of this information requirement to a very common day exercise or an example like a paint. When we normally talk about a paint, paint is looked as a device which helps in protecting the item against the atmospheric conditions on one side, and also to provide the esteem requirements of the viewers. But apart from this, depending on the specific applications of a paint, if we are talking about the paint application on a refrigerator, a few added functional requirements are established. Like, for example, the paint that is used on a refrigerator should be heat insulative so that it neither allows outside heat to percolate into the refrigerator, or at the same time it does not allow the internal heat to be transferred to the outside atmosphere, so that the items can be stored at a given temperature. But the same type of a paint, when we are talking about an application on an item like transformer, the requirements are diagonally opposite. What is required in a transformer is the paint should be a heat conductive paint as against a heat insulative paint in case of a refrigerator, so that the heat generated inside the transformer should be transmitted and radiated out into the atmosphere. Now we see that the same item paint, depending on different applications, acquires different functional requirements, and accordingly we have to add certain additives which fulfill these requirements of either heat insulation or heat conduction. In some other applications of paint, it could be electrical conductivity or electrical resistivity also. That is what we are going to consider. Well, here is the operator who has been spending all his time, effort with all seriousness and sincerity on the job. But he doesn't really know why a particular material has been used for this particular product, because that's the way he has been asked to do it by the designers. This is the place where the shape of a future product really emanates. The drawing contains many details regarding the product, like the material specifications, the dimensions, various sizes, a few lines, arches, curves, chamfers, tolerances, finishes, and whatnot. Once the drawing has been finalized, there is nothing much that can be done to improve upon the product, because the product has to be manufactured the way it has been designed and drawn. It might be realized that while it takes only a few more seconds for a designer or a draftsman to provide one more triangle on the drawing for a finer finish, or a beautifully looking curve for getting a fillet or a chamfer, it takes many more hours or sometimes days to get that feature on the product in the manufacturing site. It would be much worth spending a little more time to challenge back and have a relook into the material specifications on the drawing stage itself, or the tolerances and the finishes that we are specifying, because it does cost us money to produce a product. Though computers have come a very long way, their applications have been known in many management functional areas. Not to talk only about the product or a process, if we look into the value of the time of a designer or a draftsman, the primary requirement is to find out how much they are able to use their skills and the creativity, not in trying to find out how much time they are devoting to the drawing board. To facilitate them and to increase the value of the time of these rare personnel, there are many softwares available on the computers which are known to be saving almost up to 80 to 90% of the time, which is normally treated as a drudgery by the designers, because it is a waste of time spending it on just drawing a few lines on the drawing board, whereas the same time, if they can spend on creative thinking, they could perhaps come up with many more better and more productive designs. In every kind of industry, be it a general engineering industry, be it a chemical processing industry, be it an electrical or electronics industry, the concept of value engineering and functional analysis is equally applicable. When we are talking about an electrical industry, we might be emphasizing and talking more about terms like capacitances, reactances, inductances, conductivity, resistivity, insulation requirements, etc. While handling products in this range, it is advisable to have the close association and interaction of qualified electronics engineers when we are discussing matters connected with electronic components. Similarly, we must resort to the services of qualified electrical engineers when we are dealing with items connected with electrical industry, and the same logic holds good for association of mechanical engineers when we are dealing items with purely mechanical requirements. This is a soft starter which is primarily aimed at providing a smooth and graceful start to electric motors. The main objective is to reduce the maximum demand, and in some of the modules we might even result into conservation of energy, which are called as energy saver modules. This whole assembly is made of many components which can be broadly split into the electronic component range, the purely electrical components range, and here is the mechanical structure to support all these components. Within this whole set, we can talk about one single item that is called a bus bar, which is nothing but, in principle, a simple conductor of current. The function of a bus bar can be divided into two main parts. One is the primary function, which is to conduct the required amount of current through the system, and second is a secondary function, which is to provide a certain minimum surface area for dissipating the heat generated in the system. The heat generated in the system is a function of the resistance of the conductor and the current passing through that. To have a detailed idea about this, if we look into the structure of the existing bus bar, we start with the initial input of a cross section of about 50 millimeters by 12 millimeters copper cross section, which is extended and being connected with another conductor here, which is about 25 millimeter by 12 millimeter. We must observe here that whatever current is passing through this section has to pass through the thinner section also, which means this section is good enough and sufficient enough for conducting that current. But the basic question is, why do we use almost double the cross section in this part? Further explanation to this question, the light is thrown on one single requirement at the user end, that the user has lugs which are larger in dimensions, and it requires me a larger cross section to be incorporated in the bus bar to accommodate the lug at the user's end. Once this function is identified, our problem only remains to find out an alternative how to accommodate the lug at the user's end instead of having to provide the costlier version of copper by way of a larger cross section. Even seemingly simple looking subassemblies or components all will have more than one subcomponents or various features. Like in the case of a simple bus bar assembly, if we see in the component here, this itself is made of 6 different components. First is the smaller 25 millimeter by 12 millimeter copper bus bar. Second is the 50 millimeter by 12 millimeter copper bus bar, a bolt, a nut, and 2 spring washers. The function of the spring washer is to hold the 2 components together so that continuity of current can be ensured. While the primary function of this bus bar is to conduct the required amount of current, the secondary function is to accommodate the lug at the user's end that would be connected to this bus bar. When we look at the lug, this is the type of a lug that comes, which might vary in dimensions and shapes at the user's end. Now when we have to connect this lug to this bus bar, we do require a much larger contact area than what is available at this end. And this, friends, precisely is what is forcing us to go for a wider cross section and a wider thickness, wider width of the whole bus bar, just to accommodate this. This lands us into a particular situation where we are forced to think about fulfilling this functional requirement without having to compromise with so much extra copper, which is a very costly component and material incidentally, because it's an imported component. Once having identified this functional requirement of trying to accommodate the lug, we can find out various alternatives. Like one of the options could be like this. We can have a component right from here to this place, the same equivalent of 25 millimeter by 12 millimeter component, but only in the place where I have to accommodate the lug, I might provide a wider cross section. We will now consider the requirements of an item like the high lamp sheet, which is just like any other item used here, what we are seeing in the assembly. The primary function of this high lamp sheet is to provide insulation to the rest of the body of the cabinet of the panel as against the high voltage of the system, which can go up to 500 volts, because the components that are mounted on this part are the heat sinks, which in turn are activated by the thyristors inside, mounted on the brass sheets or sometimes on the aluminum sheets from inside the system, and are connected to this body by the nuts and bolts as shown here. Because the heat sinks are a live body exposed to voltages normally up to 415 to 420 volts, but in some cases which can even go up to 500 volts, it is required to be insulating the body from the system, and that forces us to use a product like high lamp. If we consider the requirement in its simplest form, what it really matters is how to insulate the heat sinks from the body, and perhaps this is not the only solution left to us. Let us see the possibility of using an insulated strip instead of the present brass or aluminum strip that we are using. Once I use an insulated strip, this can be directly mounted onto the mild steel sheet of which the rest of the structure or the panel is made, thereby helping us out in eliminating the requirement of high lamp sheet, which is incidentally one of the very costlier components costing us almost in the range of anywhere between 600 to 800 rupees per sheet. Testing, inspection, quality control, these are a few of the many names that have been given to a specific management function of verifying whether a product has been manufactured as per the specification or not. The specifications and the parameters can be in different subject modes, like purely on the mechanical side as far as the strength, stresses and strains are concerned, or on the electrical side like the electrical properties of conductivity and resistivity, or they could be on the chemical parameter side like resistance against certain acids or alkalis. All that is expected out of the inspection or testing division is to take up the components or the products, put them under test conditions to fulfill these parameters, and once they are satisfied that the product meets these requirements, the product is okayed. The inspection department is not the right agency normally which can question the validity of these requirements of parameters. This questioning can only be done by the designer of the product. The inspection process ends once the product has been put through the physical, chemical, electrical and other subject parameters. The objective of any wave function organizing is that ultimately we want that everyone in the organization should talk only about the value and cost and function. Well, this can be a very long drawn effort, taking a course of years, but it can be very easily done in an organized and planned way, spread over maybe 5 phases. The first phase, that goes by value engineering cell formation, can be initially created in those organizations who have not yet started this activity. This can be performing directly under the control of the chief executive of the organization, whose job will be only to take up some selected problem areas in the organization, show certain results using the basic concepts of value and functional analysis, gain confidence of the system, and subsequently under phase 2, we can create a value engineering department whose job would be to spread this activity in all the functional management areas of the organization. In the third phase, once the initial confidence has been gained, we can think about creating value engineering teams. These teams would be performing the same activity and same job as value engineering cell was originally performing in a central location, but these will be spread in all the functional departments of the organization. In the subsequent phase, once enough results have been seen and a good amount of confidence has been established, then we can think about creating value engineering circles, thereby incorporating even the lower down workers, not necessarily only the engineers and the executives, so that they can play their role. And in the final phase, once people start taking this a good part or an effective part in this activity, then we can look forward to creating a value engineering culture. And that will be the stage where we can expect each and every employee of the organization to be talking and thinking only value and nothing else.